For the lab 2 question 2, the question asks to write a full program that will create 5 processes called original, clone 1, clone 2, clone 3, and clone 4. This program will need to display a message that illustrates the parent, child, or children relationship between 2 processes. Based on the process tree given here, you can see how the flow of the program is. And then they also need to print several outputs as stated here. And then for this question, I'll be using Fedora to write a coding for this program. The first one is I need to include the library for the coding, and then I use integer main, and then first thing first, I initialize 5 variables such as original, clone 1, clone 2, clone 3, and clone 4. Next one is original equal to get PID. This function is used to get the ID number of the original, which is the parent function. And then after we create the parent function, which is original, we create a clone 1, which is a child process. Clone 1 equal to 4. Inside the clone 1, we use if clone 1 equal to 0, means when we move into the clone 1 function, clone 2 equal to 4. When we say clone 2 equal to 4, this means that we have created another child function, which is clone 2 under clone 1. Okay, and then if clone 2 is not equal to 0, the clone 1, we move back to clone 1 function. The clone 1 function will print I am obsolete version. Present version is clone 2. And then at the clone 2, you just wait and do nothing. After that, if clone 1 is not equal to 0, another child process clone 3 will be created, which is right here, original, clone 3, and clone 4. Process clone 3 will be created. And if clone 3 is not equal to 0, it means that it will go back to the parent process, which is original. The original will print this: I am parent, my process identifier is my clone of original. And the process clone 1 is clone 1, process clone 3, clone 3. The original, which is the parent function, will print this. And then if clone 3 is equal to 0, clone 4, which is another child process, will be created under clone 3. If clone 4 is equal to 0, under the clone 4 will be printed this statement, which is I am the most sophisticated clone. Process identifier of my parent is get PID. When we use the get PID, it means that we'll be getting the ID number from the original parent process. And after that, clone 4 will else, which will wait and do nothing, and then the return 0. Okay, that's all for the coding. My friend will be continue for the coding part using Fedora OS. That's all from me. Thank you.
Okay, I will continue for the simulation part using Fedora. Firstly, we need to compile the code, which is using gcc lab2q2.c. Then we need to execute using the ./a.out. Alright, this is what we get. This is the output. The first line is I am parent. My process identifier is 3417. This is the ID we get from the get PID. Which is the original process. Then my clone are process clone 1, which is 3418, and process clone 3 3419. Which means we get this 3417, which then this 3418 here, clone 1, and process clone 3 which is here, we get 3419. And the next line, this is from clone 4. I am the most sophisticated clone. Process identifier of my parent is 3419. This we get from the this is the same as process clone 3 ID. The ID we get is because the clone 4 is below the clone 3, inside the clone 3, so we get the, and we need also the ID child 3 here, so we get the same as clone 3. Then I am obsolete version, recent version is 3420. Yeah, this is the ID for clone 2. I am obsolete version here, clone 1 process print output as follow. I am obsolete version, recent version is ID child 2, so we get the ID child 2 here. That's all for the simulation part. Thank you.